Let's start with some Heightfields basics. So what are basically Heightfields? Heightfields are nothing more than just two-dimensional volumes inside of Houdini. And you can see that if you drop a Heightfield node. By default, you get this flat plane, which is not basically a geometry plane. It's a 2D volume. And if you inspect the node, you will see it has 500 by 500 voxels and only one voxel in the third dimension. So it's two-dimensional. And the only thing that you can manipulate per voxel is its height, hence the name Heightfields. The Heightfields itself, the node is very simple, it has only a couple of settings. You can set the orientation, by default it's oriented to the ground plane. You can set maybe the initial height if you need for any reason, or the initial mask, because if you see again by inspecting the node, there are two volumes, one height, one mask, and those are the two basics volumes for Heightfields. Masks are like denoted in red color. Fully masked is fully red, and not masked is 0. Then you can set up the size, create the biggest bigger or smaller. Right now by default it's set to 1000 Houdini units or 1000 meters. Maybe the most important setting here is the division mode, which has two options, by size and by axis. By size actually looks at the grid spacing at the size and divides size by grid spacing to get the number of voxels per axis. So if we have a size of 1000 and grid spacing of 2, you can see we have like 500 by 500 voxels. And if I switch this to 1, now we have 1000 by 1000. The other option is set by axis, and it's not scale dependent. You can like actually set the number of samples per axis. So right now by default it's set to 512. You can see we have 512 voxels, and I can like change that, increase it, and then you'll see it gets increased. So let's get back to basics by size and the grid spacing to 2, so we can like go and check some of the most important nodes that we have in Houdini for Heightfields. So as you realize, we have height and mask. Those are the two main volumes that you can manipulate inside of Houdini. We'll go through manipulating height first and mask later. So for manipulating height, one of the probably the most relevant nodes are first of all the Heightfield pattern. You need to connect it to the left side, because the right input is expecting a mask and the left input is connecting the actual Heightfield. So the Heightfield pattern node, what it basically does, it adds a pattern to the actual Heightfield. Out of the settings, you can set your combine method. If you're combining with something which you already made, you can replace, add, subtract your basic operations. You can set the desired height. You can maybe blur the pattern itself. You can choose the pattern if you want some specific pattern. You can maybe rotate it if you want. Set the size of specific elements of the pattern, maybe scale it per axis. And over here you also have some pattern specific options. For stripes you have stripe width, and from some others you have other options that you can actually manipulate. You can also distort the pattern, which basically just uses let me just disable the grid for now, which just uses noise to distort the entire pattern and kind of shuffle the data around a little bit. If you ever use Houdini, these are the standard options you have for Houdini noises. You can choose the noise type, the amplitude or the strength, and what's like the element size. So that's kind of the basic options for the Heightfield pattern. Then you have the Heightfield noise, which actually adds the noise to the Heightfield. And by default, you get this kind of a muddy, rocky looking thing. The node itself is similar to the pattern one. You have your combine method. Right now it's set to add. And then you have your options for the noise. Same as before. Amplitude is basically for the height. Element size is like how detailed you want it. You can even like choose to scale it on particular axis or offset, move it. But you can also have, unlike the pattern node, right here you have a much larger set of noises that you can choose from. So you can choose like basically from any of the Houdini noises, like Perlin or sparse convolution, maybe Worley cellular, and you can also choose the fractal type for any of these noises, along with setting up the octaves or roughness and stuff like that. What's interesting for this node is you also have some post-processing that you can do, where you can either kind of fold or like invert or the node. So maybe you can go either for some like not mountains, but maybe for some hills, or adjust the gain or bias for the specific noise. Or maybe even clip it if you want to set like a water level, or maybe call the peaks. So pattern, noise. Next one is the Heightfield project. So this node, as you can see by default, if I only connect a Heightfield, I get an error. It's because the second input is not expecting a mask like these two nodes are. This input is actually expecting some geometry that you can project to the Heightfield. So let's just add some test geometry. I'll use the trusty old pig head, and you can see. The arrow is gone, but nothing has changed because like the default scale of the pig head is way small. But if I scale it up like ludicrously, maybe not, maybe 500 will be enough. You can see that the details of the pig are actually projecting now to the Heightfield. And if I move the pig, you will see it will correspond to the project. I mean, the project node is like very minimal in settings. Basically, it works very well by default. Only thing that you can really change is your combine method if you really want to change anything, or maybe adjust the maximum rate distance. For some specific reason, but that's really not necessary. So there's a Heightfield project. Use that one to project some geometry that you already made back to a Heightfield. Then we have the Heightfield blur node, which I think is rather self-explanatory. So what it does is basically just kind of blurs the Heightfield. So if you get some very like horizontal striping that from projection, or like if you project some low poly geometry, you can maybe fix that by just blurring. The main setting is radius, or how much you blur, but you can also like set fix the edges. You can like override the border whether or not you want like to repeat or make it like constant, or just kind of keep it to the streak, which is a default setting. But it doesn't only have to be like the blur method. You can choose between some other methods, for example, like box blur, which gives a little bit different, or maybe expand, which kind of inflates the Heightfield and tries to kind of expand it, or maybe shrink, which does the opposite thing. Sometimes like can sharpen it up a little bit if that is the fact that you're looking for. And you can of course like change these nodes to get some interesting results. Maybe you can like blur it first to kind of soften up the details, and then you can shrink it to sharpen up some specific areas. For example, I think that if you play around with these things, that you will find out even some better cases than I did. Next one is the remap node, which does actually what it says. It kind of remaps the values of the Heightfield. So what's usual MO when using this node is clicking on compute range. So it kind of calculates what's the minimum maximum value of your kind of input Heightfield. Right now it has calculated like 0 and 285. So what you can do is that you can even like remap it even here. You can like scale the maximum input or the maximum output, and like scale the values like linearly that way, or you can just use the trusty old ramp to scale the values. You can just add your classic points and completely change the look and the feel of the height map, or just use one of the process, for example, just steps, and maybe kind of simulate terracing a little bit. But we'll talk more about terracing a bit later. Next one is the distort node. So what is interesting about this one is that it doesn't actually add values like the Heightfield noise node does. It actually kind of distorts, kind of shuffles around the values that you already have in the Heightfield. But you have the same settings as you usually do for Houdini noises. So you can adjust your like amplitude and element size and tweak the parameters that way. But you can see like where there is no value, like here it's 0, it's not actually doing anything because it has nothing to shuffle around. But this one is interesting too for adding some maybe like high frequency details and variation on top of your height field. And you can also kind of choose which type of noise you want, and maybe even kind of scale it in a specific axis for some like kind of desired results. I don't know. Depends on what you're chasing. Then we have some kind of very specific nodes, which are I don't know, a bit more complex, a bit bigger. So let's kind of maybe take this. I don't know. Let's take this Heightfield noise and just change it back maybe to sparse convolution, just so we have something to work with. And this is good enough. So let's say that this is our like kind of input coming Heightfield. So first node we're going to show is the Terrace node. So it does a similar thing as like remapping to this kind of staired look, but with way more options. So first of all, you need to define what's the height ranges that you're gonna terrace. You can do that manually with min and max height, or you can also click compute range and it will automatically compute the entire range of your height field. Then what you can do, you can set the fade, which basically blends between the original height field input one and the completely terraced one. If you don't want like very sharp terraces, you can change the step size, which is the height of the terracing. You can make them very small or very big, depending on what you need. You can like also offset; it just moves the steps. But what is interesting here is that you can control even the fade and the step with ramps. So you can see right now fade is completely 0, but if I switch it maybe to like a linear ramp, you can see that based on these height minimum to maximum height, it fades it kind of interpolates the fade parameter from 0 to maximum. So at the top, at the lowest min, there is no fade, and as the terraces go up the height field, they're getting faded more and more and more. And of course, you can like use any other like ramp that you want. Similarly, let me just remove fading for now. You can do the same thing for the step size. So you can see here it says max step size. So that's a maximum step size that you can maybe set here, and then you can use the step ramp. Right now it's set to completely max 1 all the way, but if you can change that, you can see if I go to linear, I go to from 0 to the maximum size. So at the bottom like there's like very little terracing because like the step size is very small, but as the field height increases, it slowly kind of linearly ramps up to the maximum step size, and that way you can get some like really nice variation and some kind of really cool effects as well. One more nice thing is the undulations, which basically you can just add a little bit of variation even on top to the terraces themselves. We're just gonna add the noise on top. I think that you'll have much better control just using a Heightfield noise node on like separately than using this one. Okay, so next node is the road node. This node is basically a simulation node. If you select it by default, you'll see it has some kind of turns on visualization automatically. So we just disable that and go back to the node, so we have the old colors. So what's specific about this node is it actually simulates erosion over time. And it has like thermal erosion, wind erosion, rain erosion, all kinds of erosion which are happening at the same time. And since this is a simulation, like a dynamic node, as you can see by the clock icon here, is that you can either just select it and then like press play and watch the node do its magic. So if I zoom in a little bit, you will see how the edges are kind of slowly getting eroded. You're getting these nice surface details across and then just stop whenever you feel like you're done. And if I scrub here, you can see it's like doing a time lapse of thousands of years. So that's one option. The second option is just coming to the node and clicking this option, which is freeze at frame, which basically just kind of freezes at frame 20. And then if you want like even more erosion, you can maybe freeze at frame 50. It will like the node will calculate up to that frame, and it will always be frozen there. Right now you can see like the time icon is gone, so it's not anymore time dependent node, and this is what you get like after 50 frames of erosion. The erosion itself node is very kind of complex. You can set like by type of erosion, like global erosion rate, hydro erosion, thermal erosion. You can set removal rate, and a whole bunch of settings which I really cannot go into right now. There is very nice documentation on Houdini's website and wiki, so you can check it out there. Default settings work very nicely for most of the cases. One more kind of simulation node is the slump node, which you can see here. What this node does is that it basically kind of simulates like debris slumping through the slopes and then collecting and building up either at the bottom of those slopes or in the crevices of your Heightfield. But what this node needs, it needs a flow field. That's why I have this Heightfield flow field node, which just calculates the flow field for you. So once you have the flow field, you can like come to the slump node, and just let me right now, maybe you cannot see what's going on because of the mask, but we can remove the mask temporarily by using a Heightfield mask clear node. So if I just remove the mask and just disable the slump, you will see, especially in these bottom parts, how there's like accumulation of debris in the bottom areas. So that's kind of the slumping. Now, like I said, every Heightfield has these two main volumes, the height and the mask one, maybe mostly focusing on the height and manipulation of the height volumes, but there are very similar nodes that can manipulate the mask layer as well. First, like maybe how you can create the mask is that one of the usual nodes that you use is the mask noise node, which just basically creates a mask based on some noise values, and then you, like usual settings that you can set, like element size, all your standard noise settings like octaves, roughness, and then you can even like complement it if you want to inverse it, set the gain, maybe clip it as well. No, the usual stuff. So then you have, as the same way you had the blur for the Heightfield, you can also blur the mask itself. So if I connect this to here, I can just kind of blur the mask, but I don't have to blur it. I can expand it if I want, or maybe even shrink it. And then like these nodes can be very useful for some finite control. One of the really interesting actually options for masking the Heightfield is this very powerful node called mask by features. So what it does is actually masks the parts of the Heightfield based on its features. So by default, it's set to mask by slope. It has many options. By default, it's set to mask by slope. So what it does, it kind of masks the Heightfield based on how steep the slope is. Right now, it's set that minimum slope angle is 20, and you can like control that, and the maximum slope angle to get specifically the slopes that you like. But what you also have the control is like how the things are masked. by this ramp over here. So you can see it has a slight fade in at the beginning and a slight fade out at the end, and you can like adjust those things as well to your liking. So that's like mask by slope. Next one is the mask by height, which is, I think, very self-explanatory. You can choose like specific parts of the height that you want to mask, or maybe you can just set the compute range, let the Houdini calculate the min and max. Then you can use the ramp to select the specific types of the height range that you want. For example, just this kind of a ribbon part here. Next one is the mask by curvature. If you compute range again, what it does is kind of masks out the area with the most curvature, and then you can like set what that max is, and then select maybe just the sharp edges of your terrain. Again, you can control it with the ramp to get even more precision in the selection. Mask by direction. It's pretty cool that you can select parts of the Heightfield which are facing a specific direction. You can set the goal angle to select what is the direction that you want to mask out, and then you can add some tolerance to the orientation of that part of the Heightfield, so you can select more or less of it. This is very nice for sometimes maybe you want to kind of mask out part of the Heightfields that, for example, snow is only accumulating on specific part, or wind is blowing for one side and you want to distort only that part of the Heightfield. And again, you have your ramp to specify the mask a little bit better. Last but not least is the mask by occlusion node, which masks by basically ambient occlusion. Right now, it's masking the unoccluded area, but if you want to create a mask which masks actually the occluded area, all you have to do is come to the top of this node. There's an option to invert mask, and right now then you will mask out the occluded areas. This invert mask works for any of the masking features, and then again you have your ramp to kind of select the specific parts of or specific strength for the ambient occlusion mask if you want. Cool. Then to kind of one more node is the mask by object node. What it does is kind of projects the similarly as the Heightfield projects the object to kind of modulate the height. You can also project the object and get the mask, as you can see here. Right now, since like the pig is, of course, like it's not matching the actual shape, which is intersected because it's working on a projected method. As you can select here, you can see that the method is project. So basically, it's projecting the entire geometry. So you get this even wider selection. But you can maybe switch to the fog volume, but then you need to actually convert this to the fog, and then you will only select the parts which are actually in the projected object. Let's go back to the project. We can also select like masking by side. Maybe you only want to project only the parts above the Heightfield. And you have your options to invert. You have your options to maybe post blur as well if you want to set some specific controls, and you have the option to combine with existing that maybe you can like subtract from the mask that we had before. As you can see, you can very easily build some very powerful procedural mask. But sometimes you want to actually remove the mask, and then you use the node which I already kind of sneak peeked at you, which is the mask clear node. What it basically does, it just clears the mask very easily, but you can select what the value of that clear is. It's by default set to 0, so it clears the mask. So we have covered some nodes that actually create and distort the Heightfields and can manipulate the masks themselves. But there are a couple of more Heightfield kind of utility nodes, which I tend to use very often. One of them is the rinse sample node. Let me just disable this template we have so we can just look at the nodes. So what does the resample does? It can kind of upres or deres your height field. So you can either specify the exact resolution, or you can use the resolution scale, which is basically a multiplier to your resolution. So if I set to 0 by 0.5 right now, you can see I went from 500 by 500 voxels to 250 by 250, and also I can like upres it as well, and you can see sometimes you can get some really nice details or upres your height field like that. I think that can be mostly visible. For example, if we go back to that eroded one and clear it and then upres that one, you can see there are some kind of a little bit chunky details over here, but if we upres down, that kind of gets cleared, of course, because you have some more resolution now. Then is the height field visualize node, which is also interesting because you can quickly kind of do some pre-visualization of the colors of the height field. Again, you should probably just compute the range so you get the specific colors. You can set the gradient here. You have some already like kind of Houdini presets, so you can like previs the colors, or maybe even load one of the layers for a specific maybe mask, and then choose the color for that. It's a very handy node to kind of just get some colors into the height field in the easiest way possible. Then the node, which is really powerful, is the heightfield layer node. So what this layer node does, it basically just combines two height fields. So let's say this is my base height field, and I'll plug this one into the second layer. So if I come here right now, by default it's set to replace, but you can like choose some other options. You can either add the height fields, you can subtract the second input from the first one, and your usual like math operation. Max is the kind of interesting one because you can use the maximum one and then set the layer offsets if you want. Maybe just kind of move the layer bottom, or maybe even kind of scale it. You have that options to do that as well, or maybe even like switch to minimum and then build something completely new, like this. What you can also do is then maybe use the blend one and then control the actual mix between the two. And last but definitely not the least, it's the height field scatter node. This node is basically it serves the same purpose as the actual scatter node, but it has some options which are very specific to the height fields. Oh, sorry, one thing that I didn't mention is basically that once you have a mask, is how you basically use it. So you can see most of the nodes have these two inputs. One input is actually for the height, and second input is for the mask of that specific node. So let's say that we have I don't know, let's say height field noise node. Let me just copy that one here. So we have this height field, and then you can use the same height fields like this as a mask. Just plug it into it. It will automatically recognize this as a mask. As you can see right now, we are only adding this noise to the masked areas. So if I show you the amplitude right now, as you can see, it's only manipulating the masked areas of the height fields. So that's how you use mask. You just plug it into the second input of any node that supports masks. Okay, sorry for that sidestep. Let's go back to the height field scatter noise. So let's say that this is our height field. If we plug that into the height field scatter, you will see that by default it kind of scatters a lot of points. It has options either scatter by coverage or by density or total points. But density is the one I kind of tend to use probably the most, and you can set what the density is to get lower or higher amount of points. You can set your outer radius or your relaxing points to spread them out even more. But the cool thing about this node, it already has an input for primitives to instance on the actual height field. So If I drop a box node and just plug it in here, you'll see, first of all, let me just scan it a little bit. And just kind of add a little bit of. So what you will see is that those boxes are scattered completely over the height field, but they're also kind of matching the normals of the height field. But you have control over all of those things. So you can like match or not match the normals with terrain. I mean, if you're scattering trees, you probably don't want to match the normals. Or you can match the direction with the slope. So do you want the orientation of the box to be aligned towards the slope? You know, it's kind of following the slope down or not. We also have some pre-built randomizations, like you can randomize the up vector or even the rotation of the jaw, and then set the instances. And that's basically some of the most important nodes you can use for the height fields, like to manipulate the height, maybe simulate some environmental conditions, manipulate the masks, blend the height fields or masks together, and in the end, scatter stuff on top of the height field. And yeah, height fields also supports the mask. You don't even have to kind of put the same mask. You can just plug in any mask into the height field scatter. See right now it's only scattering where the mask is, even though that the height fields are not the same. So I hope that this was like some cool information for us to start. So now that we have this shared knowledge, let's actually start making some nice terrains. See you in the next video.